My name's Gavin Harris. I run a team here at SkyBet called Platform Services, and we are responsible for looking after CI/CD systems and connecting services for microservices, offering that as a platform to our developers that work in the various squads throughout the business. That's my Twitter handle. If you want to hurl abuse at me after this, then cool. And I'm going to be talking about distributing tools. So it's a very small part of the DevOps ecosystem, as Andy talked about earlier, but it's a really critical part. And it's one of the things that's given us some pain points in the past, so I thought I'd just come and share. I wanted to talk about what problems we've experienced with test environments, repeatability, and how we've gone about solving those problems and where we are today. But first, to understand where we are, we need to understand where we came from a little bit. So this is what we used to have, and this is how we used to test a lot of our software. It's fairly typical, so Vagrant and VirtualBox using virtual machines with Docker installed on there, and a lot of other tools that you need bundled to be able to do things, such as Docker, Git, Packer, Vault, Chef, Ruby Gems, all sorts of other little utilities that you need to be able to test and a whole system locally. There was even Emacs installed on there for some reason. Someone asked for it. The customer's always right. We like to keep people happy, so we did bundle it in. And mostly it provides a consistent environment for developers to test their code locally using Test Kitchen, using Terraform, and utilities such as that. And it's consistent across different platforms. We've got a lot of users of Macs, and as well as Linux users, and obviously Mac didn't have Docker a few years ago, so we needed to be able to distribute that somewhere, and this is how we did it. What's the problem with that, though? Well, there's a few problems. The first of which is that we started to grow very quickly. Not a problem for skybetting and gaming, but a problem for distribution of our tools, certainly. That comes into focus a bit when you look at a tool like Terraform. It's got lots and lots of versions. It's being worked on very, very quickly. Often there's breaking changes in between these versions. When you've got lots and lots of small autonomous teams all using these tools, they don't necessarily upgrade at the same time. You know, they've got their own roadmap. They've got their own schedule of things that they want to do. We can't, as a tooling team, come along and say to them, you need to upgrade your Terraform now. But, you know, that's fine. We just needed more VirtualBox images, right? More teams, more images. Great. Carry on. Problem with that, though, is that very soon that gets out of control. There's lots and lots of different versions of software, lots and lots of different little utilities and drivers and things that you need to package in. Even the Chef DK, the Chef development kit that's sat there, we need to add things to that to be able to use it effectively. So things like drivers for Test Kitchen, to be able to use the Docker drivers and things. And those need versioning as well, and they've got to be compatible with the version of the Chef DK that the developer is using. And what about CI? You've got lots and lots of these teams, all with different sets of different tools, all trying to hit CI servers that have got a set of tools on them. You can mitigate this somewhat with things like Jenkins software collections and so on, but even that in itself is difficult to manage. And us trying to provide this as a platform for everybody else, we want to take the complication away from Jenkins and push it elsewhere, so that that's all local. You can repeat what happens locally in your environment in the CI system. That's what happens when you have this sort of thing. You get lots of rainy days, lots of red blobs. It's not a good place to be. What to do about that? Well, we had a think, and we came up with the idea of composable build tools. So we wanted something platform independent. We wanted minimal dependencies for our developers, so that it's a very low cost of startup, so that a developer can just get a laptop and start coding. We wanted a faster change turnaround. I don't know how many people use Vagrant machines here, but they're quite slow to provision, difficult to change, difficult to distribute, slow for the developers to download. It just takes a lot of time to move these things around and make sure that they work for everybody. So faster testing as well. How did we achieve this? Well, the big thing that changed was Docker for Mac and Docker for Windows. It was a revelation. Suddenly, we don't need Vagrant, we don't need VirtualBox anymore to distribute that Docker daemon. We've got native access to Docker from both the Mac, Windows, and Linux. we decided to use Go to write this tool because of the static compilation, which is really nice. The fact that Docker itself is written in Go, so we get the same access to the Docker API libraries as the official Docker binaries. And easy cross-compilation for different operating systems. So we can have a static binary that works on Linux, works on Mac, works on Windows, and it doesn't matter which operating system our developer wants to use. Also Cobra, which is a library for Go that helps you with CLI commands and things. I'll talk about that a bit more in a sec. And we created a tool called PSCLI. This is one of those DevOps tools that Andy was talking about. This is our internal one. The logo, don't ask. One of the team came up with it. It kind of stuck. It's a mermaid. No, a meow maid. Yes. So Cobra, it's open source. It's on GitHub. That's the URL. This is some of the README that comes along with it. Just to talk about this a bit, it's a library that gives you easy subcommand-based CLIs. So you can have an application called app with a subcommand called server, and you can make that command do something. Similarly, app fetch, you can create whatever commands you want. These commands are fully POSIX compliant with flags, so you can have global flags for the application, local flags for the subcommands. You can pass flags through to other commands that are being run by Cobra. And I'll show you what I mean by that in a second. Easy generation of applications and commands with the helpers that Cobra provides. So you can run Cobra init, and you've got boilerplate for a new Cobra application right there. And you can run Cobra add command name, and it will give you boilerplate for a new subcommand that's part of your application. Also intelligent suggestions on the command line, so you can misspell a subcommand and it will give the developer a nice suggestion, say, did you mean this? Automatic help generation is really good, so all of the docs from this are generated from the code, looking at the flags that are in the code, and you get automatic, nice markdown format documents. And it can do automatic generation of auto-completion for your bash shell, which is nice. Very useful. And there's a pull request there for ZSH, but it's not been merged yet, so fingers crossed for that. There's quite a few. It seems very popular now. A traditionalist, I like bash. So what does a typical Cobra application look like? It looks a little bit like this. This is a typical directory structure for a Go and Cobra-based application. So you have a containing folder called app name, a subdirectory in there called CMD, and inside there you have one Go file for each of your subcommands. Pretty simple. This is what the boilerplate generation looks like. If I were to run Cobra add version, this would add a subcommand called version to my application and create me this boilerplate here. And your code goes here. Very simple. You can start adding options and things. So just to crystallize that a bit and show you how this, what this means, I've got a little video just to show you a couple of commands running in PSCL. I'll just show you how it works. So I'll talk about this as it moves. So I'm just demonstrating the Terraform here. So we talked about the different versions of this here and how they can cause problems. So I'm just running PSCLI Terraform version. So I'm running the subcommand Terraform with our little utility. And it's passing the version argument to the Terraform command. What's happening here is we're pulling a Docker image that we maintain that has got Terraform in it. It's a little bit slow because my laptop is churning, or was when I recorded the video. And there we go, we get back a message saying running Terraform version 095, which is still not the latest, so I've got an update to do there. If I run it again with the capital V flag and tell it to use version 0711, and then again run version, I get Terraform 0711, and it's all running from the same Docker image. Just to demonstrate the flag functionality, if I run PSCLI Terraform help, I'm passing help to Terraform itself and getting Terraform's help back. If I run -- help, that gets passed to PSCLI. And then you get the help that's auto-generated by Cobra. So you can see here we've got flags that are local to the application that you can see at the top here. So these are Terraform-specific options that we've got. And then global flags for the entire application that override global things. You can insert environment variables and things into the commands that are being run. So that's what it does. Other advantages of this, and things that we've found really help developers, is that you can do things like individual local testing like this. So I don't know if anybody's familiar with Test Kitchen, but it's a testing framework for chef cookbooks. You can use it to do things like test individual configuration management, individual recipes or playbooks if you're from Ansible land, as well as full stack integration tests. So you can mock an environment in Test Kitchen that has a database server running in one Docker container, linked to a web server that's running in another Docker container that's got a PHP application on it or something, that's doing some messaging to a RabbitMQ or something, and mock that inside of Test Kitchen, having different containers talking to each other. And then you can have integration tests using server spec or inspec that can run against that platform and test that the entire stack of the application is working, including your infrastructure. So you're looking at the output of the application and the infrastructure to go alongside it, because it's testing both things at the same time. That's one use case for it. Like I mentioned earlier, popular kitchen CI drivers, some of them aren't bundled with the Chef development kit, so we bundled those in with the Docker image that we bundled the Chef DK in. So you get all of the tools that you need to be able to do things like full stack testing. Testing the same thing in CI, very simple. Whereas before we needed to make sure that a lot of software was installed on Jenkins, now all we need is the PSCLI binary and a Docker daemon, and then it's entirely reproducible from what the developer has done locally. When it goes to the CI server, they're running exactly the same versions of all of the tools and all of the code as the developer tested locally, so you get much more repeatability from local testing to CI to get your builds back. The real power of this, though, is when you start integrating these tools together. So we use this for managing Amazon and other resources as well. One popular use case is this. So build and test a chef cookbook or an entire application stack using Test Kitchen integration tests, as I've just described. Then you can use the VM build subcommand. And what that's going to do, it's going to use Packer, which is, again, a Docker image. It's going to pull the version that we distribute. It will pull the run list from Test Kitchen's configuration, and then it will create an AMI, an Amazon machine image, based off of that test suite. So you can test it locally. You can then build an AMI image locally, which you can then run locally in QEMU before you upload it to Amazon, because that takes a while, importing images into Amazon. I don't know how many people do that. But you really want to get feedback before you have to do that. Once you're happy with it, you can then use the VM build upload command, which integrates with HashiCorp Vault. It's role-based access with our federated internal LDAP and uses STS tokens. So it does all that for you behind the scenes. One command, upload my image, give it this name. It goes to this Amazon account over here, which is kind of a nice chaining of these different tools together. And we know it works because all of the versions of all of the tools are controlled. We know all of those versions work together because we can test them all together. So I was just going to do a quick demo, and then we can have a break. So I just wanted to show you a bit of code, just to give you an idea of how easy this is to knit together, because it's not complicated under the hood. It uses Cobra and it uses Docker. A lot of the intelligence is in the building of the Docker containers and the entry points, switching between versions and such. So I'm going to give this a go. I'm a little bit nervous. I'm not sure if this will work. Let's hope so. So the first thing that we're going to do, I'm going to look at the code, just to explain what I'm going to do first. So there's 3 files that I need to add to my application. And what I've got is someone has asked me to distribute Emacs with this tool for some reason. They need a consistent version of Emacs. I don't know why, but hey, customer's always right. So I'm going to add a type for this type of application class. And it's just a Go struct that contains a single Docker API. Then I'm going to add a library. Again, this is a simple bit of code that leverages one of the libraries that we've written already that's part of PSCLI, that does things like tells us which Docker image we're going to pull. It tells us what command it's going to run, so it's going to run Emacs. And it deals with things like volume mounts. So when you're checking out code from Git, instead of working on the current working directory, you can do that with the global flags and everything in PSCLI. So it works on CI as well. And then it starts the container and runs your command. It's pretty simple. Then I shall add a command using the boilerplate generation of Cobra. And I need to add a few other bits as well. So do some library imports. Our little Docker library that we've written is at the top there. And then create myself a Docker client, create myself one of my the libraries that I've just added in the slides. Add some configuration. So what working directory are we in, what arguments have we got, is there a Git repo, is there a branch, and that sort of thing. And then start the container and give me a log if it's failed. So let's give this a go. I forgot the arrows. Yeah, there you go. Configure Docker clients and then run the container. So this is just the code that I've just shown you on the slide. So the first thing that we need to do is add a type. So I'll do that. Add a type with a bunch of others in there. Then I need to add the little library. So library, not a lot to it, you know. It's what I've got on the slide earlier, so just to do some let the image options run. And now I need to add the boilerplate. So if I do Cobra add Emacs, it adds a subcommand for Emacs execution. So he's created a file in the CD directory. This is what it looks like. So this is all boilerplate by Cobra. And you can see here that this is where you add your code. I'm just going to delete it. Okay, so fingers crossed. I use those just-in-time compilation. That's to run the Emacs subcommand. That's the file. It does take a little while because it's doing just in time. It's much faster when it's a compiled binary. God. Right. Hang on. That's the end of my demo. I hope that was useful. Thank you very much.